Good morning, everyone. A special warm welcome to our respected sir, Dr. Manoj Sakya, for being here. I am Ankit Kumar Kard, and with me, my team Sakshi Keshi, Chitish Khanal, Rohit Sakya, and Nirzara Thapa. We are going to present on the topic virtualization. To start, virtualization is all about creating an abstraction layer of our computer resources. In simple terms, it lets us divide a single physical computer into multiple independent environments known as virtual machines. The formal definition is that virtualization is a framework for dividing a computer's resource into several execution environments using technologies like hardware partitioning, time sharing, and emulations. This means one physical server can act as if it were many separate servers, or we can make multiple resources appear as a single unit. The key idea is that users and applications don't see the actual hardware, they interact with the virtual resources instead. Now, one may ask why virtualizations? There are several reasons why virtualization is so widely used. First of all, it allows us to consolidate workloads from multiple underutilized servers onto fewer physical machines, which saves energy and resources. It provides secured, isolated environments for running untrusted applications, which is important for testing and security purposes. Also, virtualization can emulate hardware or configurations that we don't physically have, and it can simulate networks of independent computers for research or training purpose. It also lets us run multiple operating systems at the same time on a single machine and makes debugging and performance monitoring much easier. Because each virtual machines is isolated, faults or errors in one don't affect the others. This isolation is useful for both research and quality assurance. Now, to summarize the benefits, virtualization reduces capital expenses, maintenance costs by consolidating servers. It optimizes hardware usage, saves energy, and allows us to run multiple applications and operating systems on the same server. It also increases the efficiency and flexibility of IT operations, makes resource management and disaster recovery easier, and leads to significant cost savings. Besides the benefits, there are also few disadvantages such as software licensing, costs, and the need to train IT staff to manage virtual environments. However, these are relatively minor compared to many advantages virtualizations offers. Now, I would like to call Chitish Khanal to present how does the virtualization work.
Now, moving on to how does the visualization work? Visualization transfer a single physical server called the host into a multiple isolated virtual environments. They are virtual machines, each capable of running independent operating system and application. You might say how a software layer abstracts the host CPU, memory, and storage, partitioning these resources among virtual machines. Critically, activity within one virtual machine, whether testing software or processing data, do not impact other or the host. This enables running legacy and modern workload side by side on the same hardware, maximizing utilization while minimizing footprint. Now, moving on to what is a hypervisor. Hypervisor act as a resource allocator and isolation layer between hardware and virtual machine. When a virtual machine requests computing power, say additional CPU cycle, the hypervisor translates this into hardware instruction. It also enforces security boundaries. If one virtual machine is compromised, other remains protected. The hypervisor is a foundation for virtualization efficiency and resilience. Moving on to the type of hypervisors. Okay, hypervisor has a two category. Type 1 or bare metal hypervisor installed directly onto the server hardware. They require no underlying operating system. Examples are VMware EXXI and Microsoft Hyper-V. This has a greater performance in critical environment, data center or cloud platforms because they communicate directly with the hardware. Their lean architecture minimizes the latency and maximizes the security, making them ideal for enterprise workload. Moving on to a type 2 hypervisors. On the other hand, the Type 2 hypervisor operate at top of a host OS such as Windows or Linux. They are user-friendly tool for running multiple OSs on a single machine. Solutions like Oracle VirtualBox or VMware Workstation fits here. While convenient for development or testing, they introduce a slight overhead since the resources are shared with the host OS. There are some of the limitations, but Type 2 remain invaluable for non-production scenarios.
So I'm going to talk about the types of virtualization. There are different types of virtualization that are application, network, desktop, storage, server, and data virtualization. Particularly, I'm going to talk about three types of virtualization that are application, network, and desktop virtualization. So let's talk about what is application virtualization. Application virtualization allows users to run software without needing them to install on their local device. Instead of being processed on your laptop or phone, the application runs on a cloud server and is streamed to your device through the internet. So let's see how it works. When you open the app, it looks and feel like it's running locally, but all the heavy lifting is happening remotely in the cloud. Your personal settings, preferences, and data are stored on the server, ensuring consistency no matter which device you use. So it is useful because this approach removes software conflicts and compatibility issues. Different versions can coexist without problems. It is especially helpful in organizations where employees can use a wide variety of uh, software or devices or operating system. So real world example of application virtualization can be Microsoft Azure Virtual Desktop. This tool allows employees to access business applications from any device, whether it's a laptop, tablet, or smartphone, without having them to install anything. So next type is network virtualization. So network virtualization makes it possible to create and manage multiple virtual networks on top of a single physical network. These virtual networks operate independently as if they were physically separate. So instead of using physical hardware like routers or switches, everything is created in software. You can quickly set up firewalls, VPNs, and switches in minutes, all managed through a code or a control dashboard. It matters because it makes network management incredibly fast and scalable. Companies no longer require to invest in expensive networking hardware. This flexibility is especially valuable in cloud environments where need can change rapidly. So, real world example of network virtualization is Google Cloud Network Virtualization. With Google Cloud, organizations can build entire network infrastructures virtually. No physical equipment is required. This cuts down on cost, speeds of deployment, and ensures secure, adaptable networking. So next, virtualization is desktop virtualization. So desktop virtualization creates a full environment that users can access from any device, whether you are on a phone, tablet, or laptop. The experience is same. So it helps because everything is managed centrally. Updates and maintenance are easier. Users can pick up exactly where they left off, no matter which device they are on. It is ideal for distributed teams that need a consistent and secure working environment. For example, Geeks for Geeks, they use services like Amazon Workspaces and Google Cloud Virtual Desktop to provide the team with the same coding environment across all devices. This not only simplifies the IT management but also improves security and saves the cost of providing physical machines to everyone. So, this was my part.
Now, continuing with types of virtualization, we have storage virtualization. It combines storage from different servers into a single system, making it easier to manage. It ensures smooth performance and efficient operations even when the underlying hardware changes or fails. Suppose we have an MNC company that have lot of files and data of company to store. So now the Amazon S3 can store all their files and data in one place and access these from anywhere without any kind of issue, in secure way. As you can see in this figure, we have multiple servers connected in a single medium and can be accessed through it easily, securely, and efficiently. Moving on, we have server virtualization. Here, we split a physical server into multiple virtual servers, each functioning independently. It helps improve performance, cut cost, and makes tasks like server migration and energy management easier. Suppose a startup company has a powerful physical server. This company can use server virtualization softwares like VMware, vSphere, Microsoft Hyper-V to create more virtual machines on that server. So, as you can see in this figure, we have a single physical server which has different layers of which has a layer of virtualization layer that separates multiple virtual machines, each having independent work to do, and each can serve its purpose. Let us suppose there is a company that has different tasks to do for four different purposes. So first, a customer has to store data securely. So he or she requires a lot of space and a Windows operating system. And for another case, a customer has to host an online shopping website. So he or she requires a high traffic server and needs a Linux operating system. Next, we have a payroll system where employees' payrolls are processed. It requires greater internal memory, RAM, and must use a certain version of the operating system. And next job is like we have to run some social media campaign software for marketing. It demands specialized software tools and needs plenty of processing power. So as you can see here in this figure, we have a single physical server that is divided into multiple um, virtual machines that are used independently, having different operating system and applications to use, each working independently. So lastly, we have data virtualization. It simply integrates data from multiple sources into a single unified view. Users access data remotely without worrying about its location or storage types. Like, suppose the companies like Oracle, IBM provide data virtualization solution for like easy unified data access. As you can see in this figure, we have multiple data sources like databases, warehouses, and like Excel files, PDFs, docs, and many cloud versions. All are just merged using data virtualization, and they are used by consumers in different ways. Thank you.
So moving on to the uses of virtualization and how it benefits organizations in real world scenarios. One is resource optimization. Virtualization allows a multiple virtual machines to run on a single physical server. So basically, instead of having like one server just sitting there for one purpose, we can run some other several systems at once. For example, for handling emails or databases and websites all from the same machine. Second, cost reduction. Since fewer machines are needed, companies save a lot on hardware and electricity, hence reducing the cost. Third, scalability. It becomes very easy to scale up when demand increases. For example, a lot of e-commerce sites gets a lot of traffic during festive seasons. Hence, in these cases, it can simply spin up more virtual machines instead of buying new servers. Fourth, flexibility. Memory and storage resources can be dynamically allocated to various applications as needed. Say I'm using a video editing app that requires quite additional RAM. So the allocation can be adjusted in real time without rebooting the system. Fifth, disaster recovery. In case of a system crash, virtual machines can be restored quickly from backups. For example, if a hospital's record system fails due to some reasons, it can be brought back within minutes without starting from scratch. Next is multi-tenancy. A single server can support multiple users, each with their own separate and secured
environments. Another one is testing environments. So for testing environment, a lot of developers often use virtual machines to test new features without trying to risk their main system. Efficient deployment. Applications can be deployed quickly using ready-made virtual machine templates, which is quite helpful when setting up the same environment for many users. Security isolation. If one virtual machine faces a security issue, it doesn't affect the others. For instance, if a web server inside one virtual machine gets attacked, the database on another still stays safe. And the last one is energy efficiency. Running fewer physical servers saves power and reduces environmental impact, something that's quite increasingly important in modern data centers. Now, moving on to the characteristics of virtualization. At first, we have increased security. So, with virtualization, we can tightly control what programs inside the virtual machine are allowed to do. Hence, it protects the host system. Second, managed execution. Virtualization platforms manage everything from resource sharing to isolation automatically. This lets different systems operate independently while using the same physical hardware. Third, sharing. We can run different operating systems on the same device, like Windows and Linux, each in their own virtual environment without interfering with each other. And aggregation. So it's also possible to combine or split physical resources based on what's needed. So a powerful server can be divided into several virtual machines for separate teams, or multiple servers can be joined to power a heavy task. While virtualization is powerful, there are also some drawbacks we should be aware of. At first, high initial investment. Setting up the infrastructure, like powerful servers, licensing for virtualization software, it can be expensive initially, especially for startups or educational institutions. Second, learning curve. Managing virtual environments isn't always easy, especially if professional training is needed to handle configuration, security, and maintenance efficiently. And data security risks. So, if you rely heavily on third party cloud services, there's always a risk of cyber attacks or data leaks, especially if strong encryption and access control aren't in place. So, overall, virtualization brings flexibility, efficiency, and cost savings to the table, but it also requires careful planning and management to avoid potential downsides. Thank you.